Hi everybody, good morning, good afternoon or good evening and welcome to Cloud Summit from my side. Today I want to talk about Azure Synapse Analytics from a perspective of Power BI developer, and we will try to cover some interesting scenarios and understand how these two products work in synergy. As we are limited with time, I'll skip long introduction of myself. You can see all the details on your screens. I will just say that my name is Nikola Ilic and I like to make music from the data. So let me briefly walk you through the contents of our today's session. We will start with quick comparison between traditional and modern data warehousing concepts in order to put our discussion in the proper context. Then I will introduce you with Azure Synapse Analytics and core components of this platform, which will enable us to better understand the next unit. And that will be the focal point of today's presentation. What is a serverless SQL pool? Why should you consider it for your analytic workloads? And finally, in which scenarios would it make sense to go this way? We will then examine different techniques of using T-SQL language to retrieve the data from semi-structured and non-structured data sources such as CSV or Parquet files. And straight after that, I will cover the best practices for using Synapse Serverless SQL pool and how to get maximum from this engine. Last but not least, as I'm sure that most of you folks are pretty much interested to hear how much this toy costs, we will talk about pricing, what counts for the billing, how to manage your costs, and finally, how to save money in your wallets. There will be a small case study in the end. We don't have time for a real demo, but small case study so you can get a better feeling of different features that can be leveraged using Power BI. So the story starts with a quick look back to some concepts that were and still are omnipresent in the world of data. Okay, so in a typical traditional data warehousing scenario, as you can see in this illustration, you would go and collect your data from multiple different sources, perform some transformations along the way, data cleansing, so on, before putting consolidated data into a relational data warehouse. And this was and still is the focal point of your reporting solutions, a single source of truth for your data. And you could then build various reports from there using a whole range of different tools, such as, if you're all like me, Crystal Reports, SQL Server reporting services, or most recently Power BI, if you're talking, of course, about Microsoft solutions. The other thing, you could also build an additional semantic layer using analysis services, both on-premises and Azure Analysis Services, to create cubes and then target those cubes with reporting tools mentioned previously. And don't forget good old Excel too as a reporting tool. And if you think of traditional data warehouse, as its name suggests, like of a warehouse, you're close to true. It is like a large store. And modern data warehouse is like a big distribution center. So in this traditional large store, products are already unpacked, prepared, they're ready for use. So it's like someone extracted them from the boxes, transformed their original package, and loaded the shelves in the store. And they're ready for consuming. So I think you get the analogy with extracting, transforming, and loading ETL processes. On the other hand, in this big distribution center, well, you see how the items are being stored there. But if I need a box of, let's say, I don't know, beer or Coca-Cola, I can also pull it directly from there without needing to go to my local shop to take it from the shelf. So as you can see in this illustration, modern data warehouse accepts data from the whole range of different sources, structured, semi-structured, non-structured, and this can be, for example, graph-like data coming from social networks, data streams from different devices, data from JSON documents, CSV files. So literally anything you can imagine what is capable of storing some kind of data. Now this big distribution center can keep the data in its original form without needing to apply some additional steps in between to prepare this data for further analysis. Basically, a whole range of different data professionals can benefit of having a solution like this. For example, data analysts can use Power BI or similar reporting tools to create reports over this data, while, let's say, data scientists and machine learning engineers can create and train their models right away. The key concept here is that unifying experience that modern data warehouse provides. With that in mind, there are multiple benefits that modern data warehouse provides. From a technology perspective, modern data warehouse brings the following advantages. It is always or almost always available. Then it scales to extremely large amounts of data. It's also flexible because you can quickly get insights from literally any data source. And that, in the end, means that less time is needed for data movement and data preparation, which reduces the overall ownership costs. Do you recognize the object you see on your screen? Yes, exactly. That's the famous Swiss knife. And you can cut the paper, open a bottle of wine or beer, or even cut some smaller items, and all of that using one single tool. Now you're probably asking yourself, hey, Nikola, what on earth does Swiss knife have in common with Synapse? Well, you can think of Synapse as a single tool that can satisfy all your data workload needs. Do you need to import data from multiple different sources? Synapse can do that. Do you need to transform data before serving it? Synapse can do that too. Do you need to store the data? Synapse can do it for you. Do you need to query non-relational data or even files directly? Synapse can do that. And watch out now, do you need to query non-relational data or even files directly using plain old T-SQL? Synapse can do that. What? Yes, I hear you say it again, Nikola, so I will say it again. Yes, you can write T-SQL to query data from CSV, from JSON, or Parquet files. But more on that in a few minutes. Do you need to build machine learning models? Synapse can manage them for you. Finally, do you need to create your Power BI report straight from the Synapse? Yes, that is also possible. So as you may conclude, Synapse is a one-stop service for all your data tasks. Or if someone asks you to define Azure Synapse in 3 words, you can freely tell that it's an end-to-end analytic solution. Okay, so here is the quick, let's call it 10,000 feet high overview of different components that make Synapse Analytics integrated analytic solution. For SQL professionals, there are 2 pools in Synapse. Dedicated SQL pool is the official successor of former Azure SQL Data Warehouse. And then there is a Serverless SQL pool, which is the highlight of our today's talk. This illustration is a little bit outdated. Previously, Serverless SQL pool was called on-demand pool. Now it's Serverless SQL pool, just to clear the possible confusion. Folks familiar with Python, Scala, or Spark SQL can leverage usage of Apache Spark pool for processing large volumes of data. Then when it comes to storage, there are also a bunch of possible options to choose from, starting with traditional relational way of storing data in SQL Data Warehouse, then also Spark tables, Azure Data Lake storage, Data Lake, or all the way to non-relational document style storage mode in Cosmos DB. You can also orchestrate data movement using Azure Data Factory pipelines and mapping data flows. Finally, you can quickly visualize your data, like we said, using, for example, Power BI. And watch out, here's the key takeaway. You have all these tools under one roof, either natively, either as linked services. And you can build, manage, and deploy your end-to-end data solutions from within a web-based user interface called Synapse Studio. Okay, as you could notice on the previous illustration, Synapse Analytics offers 3 different analytic pools for performing different computations over your data. 2 of them are SQL-based, which means that you can use familiar T-SQL syntax for querying the data. Also, 2 of them are provisioned, dedicated SQL pool and Apache Spark pool, which means that you need to set some kind of infrastructure in advance. And more important, that means that you will be charged not only for computing power, but also for the storage you're using. Okay, so I promised in the beginning when I was introducing the agenda that we will try to answer to 3 key W's regarding Serverless SQL pool. What, why, and when. So let's start with what, and I will try to keep this as short as possible. Serverless SQL pool is essentially a distributed data processing system, or maybe it's better to say a query service that enables you to query data directly from the data lake using well-known T-SQL syntax. There is no any cost for the resources, storage, and so on. You will be charged only for the amount of data processed by running your queries. We will examine later what counts in the amount of data processed and how you can control it. At this moment, just keep in mind that Serverless SQL pool is a typical paper query model. In the end, you can think of Serverless SQL as advanced polybase or cloud polybase. Underlying technologies are not the same, but I would say use case scenarios have much in common. So you can think of Serverless SQL as a polybase on steroids. Yeah. Now, as we hopefully answered what is Serverless SQL pool, let's try to examine why you should consider using it. First and most important, you don't need to set up any kind of infrastructure or clusters to make this thing running. Once you create your Azure Synapse workspace, Serverless SQL pool will be created by default. And that means you can start querying your Azure Data Lake storage as soon as you create the workspace. And that significantly reduces time to analysis. As I already stressed, when you provision dedicated SQL pool or Apache Spark pool, you will pay not only for computing power required to satisfy your data workloads, but also for the data storage. Here with Serverless SQL pool, you pay zero for the data storage. Finally, learning new programming language just for sake of querying data from the data lake can be daunting for many professionals, especially those coming from the SQL world. Therefore, one big benefit of Serverless SQL pool is the possibility to use well-known T-SQL syntax to retrieve the data directly from the, let's say, CSV or Parquet files, or even from the documents stored in Cosmos DB. In full honesty, Serverless SQL pool is not a magic wand that will solve all your data requirements. So it's extremely important to understand in which scenarios you should consider using it. So let's answer our final W. When would you use Serverless SQL pool? First, I need to gain quick insight into the data that lays in my data lake. I want to see maximum or minimum value within a column, or quickly identify some outliers within a column. I will perform basic data exploration of the data that is stored in CSV or Parquet file using Serverless SQL, and then based on insights I got, I can decide how to leverage this data for further analysis. Next, I want to build a kind of relational abstraction layer on top of disparate data stored between, let's say, CSV files or Cosmos DB and relational database. This way, I can literally build a logical data warehouse without needing to physically move or transform data in classic ETL like we used to know. Finally, I want to perform simple but at the same time scalable data transformation within the data lake itself using the language I know, and that language is T-SQL. As I transform my data, it is quickly available for further digest by either reporting tools like Power BI, or maybe for loading into a relational data store like Azure SQL Database or dedicated SQL pool within Synapse. So let's check which options are available when we are using T-SQL with Serverless SQL pool. If you take a look at the database objects, here is the list of objects you can create within Serverless SQL. So the first and most important one, and one that you will use most frequently, are views. You can also create multiple different schemas, same as stored procedures. When it comes to user-defined functions, you can use inline table value functions, and additionally, you can create external tables, both regular external tables and citas. Finally, you can create statistics on your data for increasing query performance. Things that are currently not supported are tables, except some kind of temporary tables, but with serious limitations, as Serverless SQL pool allows querying only external data that is stored in Azure Data Lake storage. The next feature that's not supported, and this is important, very important to keep in mind, is caching of query result sets. That means whenever you execute the query, engine will go and scan exactly the same amount of data. So no matter if you press F5 once or 10 times for one single query, each time this query will generate exactly the same costs. Keep that in mind. And I want to stress this even more. You know, when I'm reading SQL-related blogs, all folks, when they analyze execution plans, they talk about query costs. So you will often hear something like, this query will cost you 50 query bucks. This query will cost you 500 query bucks. Here, forget about the query bucks. So we are talking about real bucks, real money. So please think twice before hitting this F5 button for no obvious reason. Okay, so you probably already realized that serverless doesn't support any kind of data persistency in between data lake storage and query result set. With that in mind, you can't create objects like materialized views, unlike in dedicated SQL pool, where this kind of intermediate storage is possible. Finally, you can't rely on objects like indexes or table partitions. You can partition files using file path function, but that's a whole different story. Okay, so let me now walk you through what you can and can't do with T-SQL statements. Well, whole set of features, or let's say almost whole set of features for select statement is supported in Serverless SQL. You can also use explicit transactions on metadata objects and perform data export using CTAS statement. Apologize, I already previously mentioned CTAS. I didn't explain what does it stand for. CTAS stands for create external table as select. So you can think of it like select something into in traditional relational databases, something like this. If you need to write cross-database queries, that's also supported, and whole set of built-in T-SQL functions, except those three you see on your screens: OpenXML, OpenDataSource, and OpenQuery. Finally, data definition language statements are also available, so create, alter, stuff like that. You can write everything in Serverless SQL. What you can't do, you can't use insert, update, and delete statements. You can't perform merge within your queries. Within select statement itself, there are few limitations. Namely, you can't use for XML match and predict functions, and also query hints are not supported. Finally, you can't combine data coming from system views with distributed data. Fine, so far we discussed what is possible, in which scenarios you would consider using Serverless SQL pool, but we still haven't explained how to get the best from this engine, or what are the best practices for your data workloads once you decide to use Serverless SQL pool. So let's start with the actions, with a list of actions you should perform in order to maximize potential of Serverless SQL pool. First one, try to place your Serverless SQL endpoint and Azure storage accounts that you are targeting in the same geographical region. That will reduce the latency for the data's network transfer. Then, if possible, convert your CSV files to Parquet format. Parquet format compresses the data, and this consequentially leads to smaller memory footprint of these files when you compare them to CSV. And additionally, Parquet is a columnar format. In many ways, resembles to column store indexes in relational databases. Because of that, Serverless SQL engine can skip unnecessary columns when reading data from Parquet files, which is not the case with CSV. And this will, in the end, directly affect not just time and resources needed for processing the query, but it will also reduce the cost of that query. Next, there is a very cool feature in Serverless SQL which is called built-in schema inference, and that enables you to quickly query the data in data lake without knowing underlying schemas and data types. However, as each handy feature, this also comes with a cost, and the cost is that inferred data types are usually much larger than the actual data types. For example, Parquet files don't store metadata about maximum character column length, and inferred data type is always varchar 8000. As I already mentioned, you can't partition the tables, but you can partition your files. That being said, you can instruct Serverless SQL to target only specific folders and files using file path and file name functions. This way, you will reduce not only the amount of data for scanning and processing, but also the real money costs. One important remark here, these two functions, file path and file name, are currently not supported for external tables except those automatically created in Apache Spark pool. Then take advantage of using CTAS whenever you can. This is really one of the most important features in Serverless SQL. Using CTAS, you can store frequently used queries to a new Parquet file and then use this single external table instead of referencing same underlying tables multiple times. So it's not a materialized view as we used to know in a traditional database, but it's still some kind of materialization. And this materialization occurs within Parquet file that is stored in data lake. On top of that, as CTAS generates Parquet file, you will get automatically created statistics when you query this table for the first time. So basically you are gaining performance improvement for subsequent queries that target this same external table. Every do, as you might expect, has its counterpart in don't. So here is the list of things you should try to avoid or at least reduce to a minimum. When you are running queries on Serverless SQL pool, carefully plan other workloads that target your storage account. Serverless SQL has a built-in capacity to resolve these kind of issues by sending requests to a data lake at slower pace, but that will obviously affect the performance of your query. Then, as I said, avoid schema inference. I know that it sounds appealing, to quickly get up and running without wasting time and effort to handle inferred data types, but you should definitely spend some time resolving inferred data types to appropriate ones, as you will reap the benefits later, I assure you. Then get rid of single large files. Instead, split one large file into multiple smaller files, and then use file name and file path functions to reduce the amount of data that needs to be scanned and processed. With that in mind, try to keep your single CSV file size between 100 megabytes and 10 gigabytes. That's it. Here we are. So do you know where does this picture come from? Remember Jerry Maguire and one of my favorite movies and one of my favorite scenes when Cuba Gooding Jr. asks Tom Cruise to passionately scream on the phone, "Show me the money, show me the money." So remember this picture. It's what Microsoft will ask you to do. I'm kidding a little bit, but in the end, I know that majority of you stayed till this point with me to hear how much using Serverless SQL in combo with Power BI will cost. And I don't blame you. That's why I've intentionally left this topic for the later part of the session. So before we proceed to specific costs, cost comparison when it comes to Power BI, let's first examine what are you paying for when you're using Serverless SQL pool alone. If you open official Microsoft documentation, it boldly says that you will be charged for the amount of data processed. But let's dig deep and check what counts for the amount of data processed. The first thing is amount of data read. Here you should count data itself, but also related metadata for formats that contain metadata like Parquet, for example. Then amount of moved data. So when you run the query, it's being split into smaller chunks and sent to multiple compute nodes for execution. And while the query runs, data is being transferred between those nodes. And these intermediate results is something you should be aware of. Same as final data transfer to the endpoint in an uncompressed format. In reality, this number will differ if you run something like select star from the file that contains 50 columns from the case when you are selecting only a few columns. Finally, amount of data written to data lake. This applies in those scenarios when you use CTAS to export query results to a Parquet file that's going to be stored in a data lake. So when you sum up these three items, you are getting the total amount of data processed. Also, you pay for statistics. As in regular SQL databases, statistics help the engine to come up with the optimal execution plan. And statistics in Serverless SQL pool can be created both manually or automatically. And in both cases, there is a separate query running to return the column on which statistics is built on. And this query also has some amount of data processed. One important takeaway here is with Parquet files, when you create statistics, only the relevant column is being read from the file. On the other hand, with CSV files, whole file needs to be read and parsed in order to create the statistics, even for a single column. And going back to our original request for showing Microsoft the money, currently pricing starts from $5 for 1 terabyte of processed data. The exact price depends on the region, and you should definitely check how much would you be charged depending on where your data is. Also keep in mind that minimum chargeable amount per query is 10 megabytes. So even though you sometimes have a query that processed less than 10 megabytes of data, you will be charged as this minimum threshold was reached. Okay, as the session is aimed to explain different use cases of integration between Power BI and Azure Synapse, here is the scenario that I've used for testing how these two products work in synergy. I was using open source YellowCab dataset, which has around 1.5 billion, yes, billion rows in total, but I've extracted only small portion of data. I have two CSV files, one for each month of January and February 2019. You see the file size on the screen. And I also have two Parquet files containing exactly the same data, and they take around 2.5 times less memory. January file contains around 7.6 million records, while February contains approximately 7 million rows. So one disclaimer here, I haven't compared performance itself, but only costs. So how much would you pay for each of different scenarios? And here is the table which shows various use cases for both CSV and Parquet files with estimated costs in US dollars and short remark about the use case. In short, for CSV files, there is no difference between using regular versus aggregated tables, as in both scenarios, the whole file needs to be scanned. When you compare import versus direct query mode scenario with CSV files, when you are importing the data into tabular model of Power BI, you will be charged number of times that matches the number of your data refreshes. So if you refresh the data once per day, you will pay only once for the amount of data processed. On the other hand, with direct query mode in place, number of visuals and the number of users interacting with the report will directly affect the costs of your Power BI solution. As you probably know, each time you interact with the visual, query will be sent to an underlying database, and each time you will need to pay for this generated query. Keep that in mind. And simply said, stay away from direct query whenever possible. The only edge case is if you pre-aggregate data within the Serverless SQL pool, but that has impact only on extremely large data sets, because the lower amount of streamed data can have an impact on the total amount of processed data. It's a whole different story for Parquet files, as pre-aggregating data in the Serverless SQL pool would do the real magic. And don't forget that Parquet keeps the data in a columnar structure, so engine is capable to eliminate scanning of unnecessary columns. Finally, here is the list of considerations you should keep in mind when you're creating Power BI solutions that use Synapse Serverless SQL pool as a data source. No matter what you perform within the Serverless SQL pool on top of the CSV files, they will be fully scanned and at the lowest level of the data preparation process. Whenever possible, use Parquet files, Parquet format instead of CSV. Also, whenever possible, import the data into Power BI. That is a general recommendation that also applies for this scenario with Serverless SQL. That means you will pay only when the data snapshot is being refreshed, not for every single query that report generates. If you're dealing with Parquet files, whenever possible, create pre-aggregated data in the form of views in the Serverless SQL pool in the Synapse. Since Serverless SQL pool still doesn't support result set cache, keep in mind that each time you run the query, even if you're returning the same result set, the query will be generated and you will need to pay for it. Finally, if your analytic workloads require a high number of queries over a large data set, so large that import mode in Power BI is not an option, maybe you should consider storing data in the dedicated SQL pool, as you will then pay fixed storage costs instead of data processing costs each time you query the data. Here, in order to additionally benefit from using this scenario, you should materialize intermediate results using external tables before importing them into a dedicated SQL pool. And that way your queries will read already prepared data instead of raw data. That was it for me. I think we are around 30 minutes. And yeah, before I wish you nice rest of the day and rest of the Cloud Summit, I would like to thank you for attending. The special thanks to Simon and Cisha.